I thought we'd start this episode of Weather in the Classroom with something topical. We've recently had wintry precipitation for lots of the southeast and even the south central U.S., areas that don't necessarily see the precipitation. A lot of people are glued to the TV, as I was as a kid, trying to figure out, are we getting snow, are we getting sleet, or, God forbid, getting that freezing rain? So how the heck do we figure out what that is? Well, there's a lot of guessing even right up to it. But here's a couple things we know and what we look for as meteorologists. So let's start with the different types, just kind of from a snapshot perspective. Rain, we know, comes down as liquid. That's when it gets too warm in the profile to support any wintry precip and it falls as liquid. Freezing rain is something that gets confused a lot. We'll talk about that one, but that falls as a liquid as well. Sleet, it initially is snow, melts, and then refreezes into something not quite as pretty as snow. And then, of course, we know what snow is. We don't get it very often, but it's always very exciting when we do. Okay, let's start with one that can be kind of confusing, and actually confused me a lot up until I was a meteorologist. So, freezing rain. You hear it, and you're like, okay, freezing, you hear rain. Well, it comes down in the form of rain, and this is really the type of precipitation you do not want. So essentially the setup we have here is you've got a system moving through. Now at the base of the clouds associated with this system, with this precipitation, are temperatures cold enough to support freezing. So you have your water droplets that are super cool that have actually turned to ice crystals and initially fall as ice crystals or snow. But between the base of that cloud and the surface, there's a warm layer where temperatures are just warm enough to cause that snowflake to melt, turning to liquid. But then right as you get to the surface, right before the surface, it could be the first couple hundred feet from where you're standing up into the atmosphere, we have a sharp drop once again to temperatures below 32 degrees. 32 degrees is the freezing point. And that causes rain to instantly freeze as it hits the surface, turning to ice. So in this scenario, you don't get anything pretty. You get very dangerous conditions, especially on roads. We see this a lot in the southeast, where your temperatures at the surface will be at freezing, the rain comes down as liquid, and then you have a bad icing event here. So let's go to the other one that this gets confused with a lot, is sleet. So sleet, a similar setup. Aloft, it's freezing, just below the cloud. It starts as snow. There's a shallow warm layer, meaning not quite as deep, it doesn't go all the way to the surface. Just in the mid-levels, there's temperatures, we call it a warm nose, because often if you look at the profile, it looks like a nose intruding within that atmospheric profile. It causes that snow to melt into liquid. But there's a big enough layer beneath there, a couple thousand feet, from that warm layer to the surface where it actually refreezes. Now because it's melted, it doesn't freeze into something pretty, you don't get the snowflakes, but you'll get these pellets that look like ice, not to be confused with hail. Hail's formed in a completely different scenario, but you'll get these little tiny ice pellets, and you'll see they'll bounce off the windshield, they'll bounce off the surface, and eventually over time those pellets can form a layer of ice, but you'll see that initially fall as these little balls of ice. So that is the difference. Sleet falls, and it actually is frozen when it reaches the ground. Rain, freezing rain, is liquid and freezes on contact. And of course the fun one, snow. We're from freezing from the surface up to the base of the clouds. You get these nice big flakes. A lot of times that's what systems will start as, and then you'll get a warmer scenario over time. So we love to see the snow. Let's talk about a couple common either misconceptions and just some things to think about. So the surface temperature, I know as a kid I'd watch the Local on the 8s for the Weather Channel, and I would look and I would hope that we'd stay at 32. I thought if it's 32 degrees at my house, it's snowing. Well, it can actually be 32 at the surface and come down as rain. In fact, it can be 35, 40 degrees and you can have snow coming down. Why? Because the precipitation that falls is determined, the type of which is determined by the temperature between you and the base of the cloud it's falling from. It can absolutely snow. We see it a lot, especially in areas like New England, the Mid-Atlantic, Great Plains, Ohio Valley, where it's 35 to 40 at the surface, but there's such a sharp drop-off between where you're standing and the base of the cloud that it's able to fall as snow. So your surface temperature does not necessarily matter for that. It does matter with respect to accumulation. So accumulation is simply what builds up, what collects at the surface. That is determined by your surface temperature. And if we're below the freezing mark, things will begin to accumulate, whether it's freezing rain, it's sleet that turns into a layer of ice, or it's nice snow that turns into a snowbank. That is determined by your surface temperature, and a mix is possible based off of your atmospheric profile. In some instances, snow will make it through that warm layer and fall, and you'll get a mix of snow and you'll get a mix of sleet. So it's not uniform, but what we look at as meteorologists, we look at the entire profile of the atmosphere. What is happening between where we are at the surface and the base of the cloud? And for instance, last week in the southeast, when you had that switch over to rain, you had warmer air that moved in as the low moved off to the north and east. And that warm air was just enough to cause that melting layer to expand and ultimately give us what turned into being a very, very cold rain. So that's a look at how precipitation is formed. Hopefully you learned something. We'll have another episode coming up. Have a great day.